Alright, so this will be part 2 of the sequences in series playlist. We'll be talking about harmonic series, geometric series, and also some other properties of series, which I will start talking about now and then get more in depth, because it starts off with very simple and basic, but then when we start talking about convergence and divergence and the special conditions which they take, and then various other functions like hyperbolic trig functions in terms of series. We talk about Taylor series and a bunch of other stuff to come. So basically it starts off simple but gets a lot more in depth. So basically we have, like I said in the previous video, the geometric series is defined as n starting at 1 going to infinity of 1 over 2 to the n. And our harmonic series is 1 over n. That's just just a name for these general typically seen series. And then here we have what is called the sequence of partial sums. Basically what this is when we have n, any usually starts with 1 or 0, typically 1, and then we go up to k, where k is a natural number. And usually we like to keep it small. Like for example, k can be equal to 6. Like in the previous video, I had 1 from n equals 1 to 6. That is a sequence of partial sums, because basically you stop. It has set theory in it. If you guys watch other video series on set theory, you'll kind of understand it. But basically, so this is written as n plus 1 plus n plus 2 plus all the way down to n plus k. And it's kind of like 1 plus 1 plus 2 is equal to 3, and then plus so on and so forth. So basically that is where the sequence of partial sums. And another interesting thing to start talking about now and get into later, we have this, and n is a member of the natural numbers, which means that you're going to sum all the natural numbers. The same thing as writing n equals 0 to infinity to of n. Same thing, because if you haven't noticed already, we are only working with natural numbers. We're not doing any decimals or fractions or anything non-natural. Integers, we can definitely take the sum of integers also. However, generally so far we've been working only in the positives, and so back in the sequence of partial sums is also defined over the naturals, at least this particular cases. And then we know harmonic series is also over the naturals. However, interesting thing to point out is, because I haven't watched a Continuum Hypothesis video series, we have interesting little problem which arises here, because it states that there's not a set's a collection of objects in where we have, which is the number of, well, actually I'm not even going to get into this right now. You guys can watch the Continuum Hypothesis video series. It'll take a while to explain. That's not really quite what I'm going for. So basically, just to review, this is the general form for the geometric series, a general form for the harmonic, 1 over n. This is the sequence of partial sums, and the n as a member of the natural numbers, summing is the same thing as writing this notation over here. This symbol here means isomorphic, which is pretty much just means equal to. It's the same thing, isomorphic. And so yeah, that's pretty much it. Basically, yeah, isomorphic could be something like, let me just write down a example really quickly. Okay, so we have something like 3 is equal to 2 plus 1. That is isomorphism. I mean, because you could technically also write this as 3 equals 3, and that's equal, but this better illustrates the point because we have something different, but at the same time it's also equal. So that is what isomorphic basically means. And so it's important to know, because when we talk about the converging, diverging series and showing how the two series are equal and why they are such, that will be the topic of the upcoming videos. So I guess I'll see you guys in the next one.